year, but we're going to cover it again because we didn't get a good shot at it last year with everything that happens. And we're going to do a lab the same day, so this won't take very long. I'm going to do this next Wednesday, and we'll do this in lab. We'll discuss it first, and we'll do a lab involving it afterwards. Okay, so LeChatelier says the reaction on stress will move in the direction that eliminates that stress. There are a total of 4 different stresses. The first is concentration. What we do for concentration, whatever side the substance is on, if it's a reactant or if it's a product. If it's increasing, if whatever side it's on, if it's increasing and it's on reactant, it's going to shift to the opposite side. Equilibrium is going to shift to the products. If it's decreasing, we pull more to that side. We'll talk about that more in detail. Temperature. Temperature, we have to understand there's 2 types of reactions in terms of temperature. Exothermic or endothermic. Exothermic reactions are products. Endothermic reactions are reactants. Energy is reactants, sorry. Okay, it's same thing. Opposite, shift to the opposite side. If you increase, pull to its side if it's decreased. Pressure. Pressure only deals with gases, so we're going to have to deal with Boyle's law. Remember we talked about Boyle's law last year in gas laws? Boyle's law, pressure is in inverse relationship to volume. So if pressure goes up, volume goes down. Volume goes up, volume goes down, pressure goes down, volume goes up. All right, and we'll be using that to determine the amount of space in order to determine which way the reaction is going to shift. The last is the catalyst. Remember, catalyst increase rate of reaction without being involved, always no shift. It doesn't actually make the reaction shift, it just gets it there faster. So let's take a look at the following. Temperature. In this reaction up here, temperature is a product. So if I increase it, I'm putting more in, it's going to the opposite side. This is going to shift to the reactants. Okay? Pressure is increased. Well, in order to balance this up, and to balance this up, bariums are fine, chlorines are fine, oxygen's not so much, so we'll put a 2 here, a 2 here, and a 2 there. Now, how many moles of gas do I have? Well, I have 1 mole of gas because that's aqueous, it's not a gas. Over here, I have 2 moles of gas. So I have 2 moles of gas on the product side, 1 mole of gas, increasing pressure, decreasing volume, less space. We're going to shift to the reactants. All right, concentration of oxygen is increased. Oxygen is a reactant. We shift to the opposite side. This is going to shift to the products. And then manganese dioxide as catalyst is used, always no shift. All right, now that was real quick. We'll go over that again, this exact one again in class. Copy this one. We'll also discuss this in class before we do the lab on equilibrium, and I'll post that as well. Hope that wasn't too bad. Take care. Be good. Bye.